Good afternoon, everyone. Good afternoon. Hope everyone's doing all right. So, gonna give everyone a chance to get in here and get logged on and all the good stuff, and then we'll get started. All right, looks like everybody's in. So, hopefully, and I believe you guys did see, at least majority of you did see the email I sent out last night. Chapter two's definitions weren't that many of them, and we're gonna actually talk about some of them as we go throughout the lectures. You see, if you look at the screen, you see we're starting off with 2.1 today. So it's different, few things in chapter two that I want to make sure we touch on, just in case, just to make sure we have clarity moving forward before we jump into chapter three. So we'll walk through chapter two's content, stuff like that, some calculations in chapter two as well, and go from there. But now you have
I got a question. So wait, is chapter one due already, or when is the chapter one?
I was about to say that. That's exactly what I was about to say.
Okay.
So chapter one and chapter two definitions are due on September 4th. And so if you have any issues with those date or that date, always make sure you communicate something to me, something crazy happened or whatever. But September 4th is the due date for your chapter one and chapter two definitions. Some of you already sent them to me as far as chapter one is concerned. And so yeah, just gotta
Oh,
knock out
I didn't mean the definition. I meant the sections. When is that going to be due?
the what?
The sections
You talking about the actual homework?
yeah.
That is due December.
So everything is due December.
Yes.
Oh, okay.
Yep. Outside of the definitions, because we want to solidify that as your foundation moving forward. But so that's why I put a due date on your definitions. But as far as your homework assignments, yeah, all of those are due by December, whatever date I put in there. So now, what you most definitely don't want to do is just be getting started November 30th type stuff. You know what I mean? You want to make sure you're doing this work as we move throughout the course. So the way you know that you are behind is that you gauge the lectures. If we're in chapter 4 and you still dabbling in chapter 1, chapter 2, you need to pick up the pace a little bit to get caught up. But you have the room to get caught up with those due dates being out there in December. All right. Any other questions before we get rolling? Anybody? All right. So we're gonna do a couple sections today: 2.1, 2.2. So looking at 2.1, data types and levels of measurement. So the first type of data, first two types, we have qualitative data and quantitative data. Qualitative data consists of values that can be placed into non-numerical categories. And this over here. And quantitative data consists of values representing counts or measurements. And of course, I'll give you guys a chance to write this stuff down. But if ever I scroll up and you're still writing something, or you need me to slow down or anything, just let me know. It's not a big deal.
I have to get the paper real quick.
Say again now.
I have to get paper real quick.
All right. All right. So we looked into the example, classify each as qualitative or quantitative. First, we're looking at brand names of running shoes. All right. So remember, our choices are qualitative, quantitative, qualitative, non-numerical categories, quantitative counts or measurements. So when we look at that first, when you're talking about categorizing your shoes, say you put your Nikes in this stack, Reeboks in this stack, Adidas in this stack, that would be considered qualitative, non-numerical categories. All right. Scores on the exam. That's going to be quantitative. Measures your scoring and counts. All right. Next one, letter grades on an essay, qualitative. And then last one, numbers on uniforms that ID players. So this one you have to be careful with because these numbers are being used to identify the players. So those numbers don't have any measure or count on anything. So they will actually be qualitative. All right, questions on either one of those before we go to the next step? All right, can I scroll up? All right. So the next two sets of types of data, we have continuous data and discrete data. Continuous data can take on any value in any given interval. So when we talk about continuous data, think about measurement. And you'll see why when we look at our examples in a second. Discrete data can take on only particular values, not other values in between. So we see some examples of what we're talking about in a second. Just give you a chance to write it down.
So for option B or letter B, when you said the scores on the exam, why would that be quantitative if it's, is it like for the grades as a whole or just like individual grades?
Because they carry numerical value. So like a 95, carries more weight than a 90. Here, if I were a number 95 on my back, that has no numerical weight. Like I'm not a better player because I got a 95 and you got a 90. You see what I mean? So that 95 is just to
Okay.
identify. Mhm.
Thank you.
Yep, no problem. All right. Now going back to that example, if that meant something like that, then this would be quantitative. So if my 95 means I was a better player than the next person who has 91, then it would be quantitative because now that has numerical value. Yeah. All right. So let's look at a couple examples of discrete versus continuous. So the first one, the number of A's earned in a section of statistics with 15 students enrolled. So when it comes to discrete, remember they can only be particular values. There's no fluctuation. So when you're talking about discrete, it's either 4 A's in the class or it's not. If it's 15 A's, then you got 15 A's. There's no such thing as 15.1 A's or 15.135 A's. It's just that number, and there's no deviating from that. Then it's considered discrete. And so that's what we have here, the number of A's earned in a section of statistics with 15 students enrolled. So that's considered discrete. Now, remember I said the key to continuous is measurement. For the most part, anything you see dealing with measurement or weighing something, a scale or something like that, it's going to be continuous. So you're talking about the weight of a sandwich at the deli. So if my scale can be more accurate than your scale, and your scale can be more accurate than the next person's scale, and all of them can still be considered correct, then that's what we're talking about being continuous. So if you weigh a sandwich and it's 5 grams, somebody else weighs a sandwich and it's more accurate and they got 5.1, and somebody else weighs and it's more accurate and it's 5.12. All of those are correct. It's just that one scale is more accurate than the next scale. And so all of those values are considered continuous. So measurement will be considered continuous data. The number of cars that pass through a McDonald's drive-through in the next hour. So once again, there's no such thing as a 4.5 of a car or 4.51. It's either four cars or it's not. So that will be considered discrete. And the last one of this example, the speed of a car that passes a state trooper. So we're talking about state trooper once again. He has his gun out, his radar gun, and he's clocking these cars that are driving past. Once again, there's a possibility we're measuring their speed. There's a possibility that my radar gun could be more accurate than his radar gun, which could be more accurate than the next person's radar gun. Once again, if you're doing anything with measurement, that's going to be considered continuous. Any questions? Any questions? Now scroll up. Everybody okay? All right. So for the next one, levels of measurement, I was trying something out because I know when I'm writing, I can sometimes get a little messy with my hand writing. So if this works out better, then we should be good to go. I just want to make sure it's able to be seen, words weren't small enough, too small or anything like that. So looking at levels of measurement, the nominal level of measurement is categorized by data that consists of names, labels, or categories only. Notice this is qualitative data. Ordinal level of measurement applies to qualitative data that can be arranged in some order, such as low to high. Interval level of measurement applies to quantitative data for which intervals are meaningful, but ratios are not. And then for ratio level, oh yeah, well, I'll read that other part later, but for ratio levels of measurement applies to quantitative data, which both intervals and ratios are meaningful. So notice the first two are qualitative, the second two are quantitative. All right, are we ready to go to the examples? All right, so identify the level of measurement, nominal, ordinal, interval, or ratio for each of the following sets. So I already wrote the answers down, but we can walk through it and talk through it, see if we can make sure we have clarity on it. So the numbers on uniforms that identify players on a soccer team, kind of already talked about that to some degree already. They may be numbers, but those numbers are used to identify the players. So that's going to be nominal, categorized by names, labels, or categories only. Next one, student rankings of cafeteria food as excellent, good, fair, or poor. So once again, we're looking at a qualitative type of data. And in this case, we're talking about being arranged in some order, such as high to low. So that would be ordinal for us. Next one, calendar years of historic events such as 1776, 1945, and 2001. So this is the quantitative set of data, the numbers that we can use to count, counting and measure. And so the intervals are meaningful, but the ratios are not. So here, the ratios aren't a big deal to us. And we're using those to categorize our historical events, calendar historical events. Now, the next one, temperatures on the Celsius scale, that's going to be interval as well. And the reason being is because of this statement right here, data at this level have no arbitrary 0 point. So the 0 here, it represents freezing point, but it does not represent no heat. So in other words, they were trying to say that at 0 degrees is kind of arbitrary. Is have an arbitrary 0 point. So that's why that one is considered interval. And then this last one is considered ratio. You're talking about runners' times in Boston Marathon, and that's because the ratio matters. So if you run the marathon in 3 hours and you run it, and somebody else ran it in 6 hours, the fact that they ran it double the time you ran it, or vice versa, it matters. So the ratio does matter. They do carry meaning. All right, questions before I scroll up?
Still writing.
Yep, no problem.
I'm good.
Thank you, sir. All right, so that's it for 2-1. Everybody good before we go to 2-2? All right, so 2.2, dealing with errors. So random errors occur because of random and inherently unpredictable events in the measurement process. So an example of that, let's say in a hospital, you're measuring a baby and mistakenly shake the table. So that will be considered a random error. Mhm. Systematic errors occur when there is a problem in a measurement system that affects all measurements in the same way. Mhm. So an example of that is after measuring babies all day, you notice that the scale reads 1.2 pounds when there is nothing on it. So that means that all of the weights or all of the weights of the babies that measured with that scale on that day should be 1.2 pounds off because that was done throughout the whole day and it wasn't caught. Any questions? Any questions? Scroll up. Just let me know if I go too far up. Absolute error describes how far a claimed or measured value lies from the true value. That don't purple. All right, so to calculate the absolute error, you would take your claimed or measured value and minus the true value. Anybody holding on to green? All right, relative error. It compares the size of the absolute error to the true value. And it's often expressed as a percentage. Mhm. Where you calculate relative error, take the absolute error, divided by the true value, multiply times 100%. All right, so example we have here, find the absolute and relative error. Let's see, I want that to be another color. All right, so we're looking at find that absolute and relative error. So they give you your true weight is 100 pounds, but a scale says you weigh 105 pounds. All right. So the absolute error, you take your measured value and you minus the true value. So your true weight is 100. The scale says you're 105, so it's 105 minus 100, which would be 5 pounds. All right. Then to find the relative error, you take your absolute error, place it over the true value, then multiply it times 100%. So that'd be 5, which is our absolute value, over 100, which is our true value. That gives us 0.05. Multiply times 100%, that'd be 5%. There was. All right, questions. I'll put the statement up here before. That's how that will play out if we had to make a conclusion based on the information we just calculated. All right, questions on anything so far? All right, so that's it for 2-2. So next class we'll be looking at 2-3. There's no real rush, not like I have to cover all of chapter 2 in one day. So that's the first 2 sections. If you look in math lab, or if you saw it earlier in math lab, maybe a couple days ago, you had 2-1 through 2-4, but 2-4 was optional. So I took 2-4 out. So we're only going to be, you guys only going to be held responsible for 2-1, 2-2, and 2-3. So next class, we'll look at 2-3. We may get into chapter 3, not sure yet, but there's no rush in trying to do all of the sections today. So we'll stop right here. 2 sections is a decent amount of information. There are a couple definitions that I did not emphasize in our lecture, but they're pretty much straightforward. So, that's a part of your assignment. So we didn't do all of your definitions. So you do need to go and check out. There are a couple of them, not that many. Most of the definitions we did cover in our lectures today. So with that being said, questions before we close? Make sure we're good and everybody has clarity.
Actually, just about these Zooms for like for section chapter 1. Are you gonna, where did you post those at? I might have missed it.
There's no Zoom for chapter 1. They were all definitions. So chapter 1's definitions were your assignment. So now if you have questions on anything that you came across, then the door is always open. You know, just like now we have opportunity for you guys to ask questions if you have them. But there are no lectures for chapter 1.
Okay, so when we do the homework, just kind of look in chapter 1 to get a more understanding about it, or if we have any questions, just reach out.
Yep, look at your definitions that you already generated.
In math lab.
Say again.
Math lab. So
Right.
you said look at the definition. Okay.
Yeah, majority of it should be based on those definitions that I gave you to look at. But like I said, though, if you see something that you want to discuss, feel free to bring it up in class. It may be something that I may have even missed and then put in those definitions and stuff like that. So yeah, feel free to ask whenever. But yeah, so you should be covered though with chapter 1 stuff and the definitions and stuff. But it's a new book, so I might have missed something. But yeah, for sure, let me know. And even if it's something that's up there, just if you have a question on it, feel free to ask.
Okay, thank you.
Yep, no problem. Anything else? Anybody else? Everybody good?
Yes. Where do we turn the definitions in at?
You will email them to me, vtucker@tcc.edu. So you can, if you wrote them out, then you take a picture or scan them. But if you just type them up in Word, then you just shoot them to me in a file. But just email it to me.
Okay. Thank you.
Yeah, no problem. Anything else? Anybody else? Make sure we're good. Everybody okay? All right. So like I mentioned, next class, we'll look at 2-3. That's our last section out of chapter 2. We may jump into chapter 3, we may pull back. We'll see. Other than that, you guys have a good one. Be safe. And I will see you on Wednesday.
Y'all going.
Thanks. You do the same.
Thank you.
Take care.
Thank you too.
Have a good evening.
Thanks. Y'all do the same. Thank you. Have a good one.
Thank you.